Now let's see this algebraic structure. So this is the basics for the group. In order to understand what a group is, you should understand what an algebraic structure is. So if you have a set and if you can define a binary operator on this set, let's say a set capital S, a non-empty set capital S is called an algebraic structure with respect to binary operation star, which means we generally talk about a set with respect to an operation. Okay, so you should have two things here. One is you should have a set which is non-empty, which can be finite or infinite, and other thing is you should have a binary operator. So when you have these two, then we talk about it. Okay, so if you have a set and then with respect to a operator, okay, with respect to an operation star, if a star b belongs to S, for all a comma b belongs to S, which means if you have a set of elements and if you take any two elements and if you apply the binary operation, if the result also should belong to the same set, okay, then that set is called as algebraic set. Okay, algebraic structure with respect to the operator. It is also nothing but we are talking about the closure property, right? So for example, you can think of it like this. Assume that we have a set capital S equal to two elements, 1 comma minus 1, that's it. And now I am defining a operator. Here in this case operator is, let us say, multiplication. Okay, so star is nothing but multiplication here. Now when I talk about this set with respect to the operator multiplication, is it going to be an algebraic structure or not? This set along with this operator is going to be algebraic structure or not? When can we say that? If whenever you take any two elements of the set and then if you apply the operator, if you get one of the element in this set, then it is said to be algebraic structure. Now we have two elements here, so let me take those two. 1 multiplied with minus 1, which is nothing but minus 1, the result belongs to this, right? And similarly you can take 1 into 1, which means I am repeating the same elements, it is nothing but 1, again it belongs to the set. And again minus 1 into minus 1, it again belongs to the set, right? Therefore what we found out is this particular set and this particular operator, these two can be called as algebraic structure because this set is closed under this operation, which means if I take any two elements from this set and if I apply the operation, I am getting one of the elements in this set. That is called as algebraic structure. So let's see one more example. Let us say capital S is a set of sets. Okay, so one is 5 A, B, and then AB. So capital S is set of sets, and let's define an operation star. In this case, let's say it is union. Okay, now what can you say about this combination, this set S with respect to the operation union? Is it going to be an algebraic structure or not? When can you say that it is an algebraic structure? If you take the union of two elements, which means if you apply this particular operation on any of these two elements, if the result also falls in the same set, then we can say that it is algebraic structure, right? So let's see this. You can take any two elements and if you try to apply union, definitely the result is going to fall in the same set. You can try with anything. If I take 5 union A, the result is going to be A itself, and the result falls here in the same set. That is why this particular set is closed under the operation union, right? Therefore we can say that this particular set is algebraic structure with respect to the operation union, right? And now you can even think about something. So let us say capital A is a set having elements 1, 2, 3, and capital S is, or let us say capital R is set of all reflexive relations. Okay, reflexive relations. Now what can you say about R comma union? So it means that if you take two reflexive relations and if you apply union, will the result also be a reflexive relation? Yes, it will be a reflexive relation. Therefore you can say that the set of all reflexive relations with respect to the operation union is an algebraic structure. And similarly you can say that set of all reflexive relations with respect to the operation intersection. If you take two reflexive relations, if you take the intersection of two reflexive relations, the result is going to be reflexive. The reason is if two sets are going to be reflexive, they are going to contain all the diagonal elements, and since both the sets are going to contain diagonal elements, if you take the intersection, the resulting relation is also going to be a reflexive. So I can say that set of all reflexive relations are closed under the operation intersection, and therefore the set of all reflexive relations with respect to the operation intersection is an abelian group or abelian structure, not a group, abelian structure. You can think of it like that. Similarly, the set of all reflexive relations are closed under the operation union, therefore the set of all reflexive relations with respect to the operation union is an abelian structure. So till now we have seen the definitions, or we have seen the sets on only the finite sets on which this abelian structure is defined, but it can even hold true for infinite sets as well. For example, if I have set of all real numbers, right, and if I take the operation plus, what can you say about it? Set of all real numbers are closed under the operation plus or closed under the operation addition, which means if I take any two real numbers and if I add them, the result also going to be a real number. Therefore, since they are all closed under the operation addition, we can say that set of all real numbers with respect to the operation addition is an abelian structure, and in this case R is a real number, R is infinite. Therefore a set can be finite or infinite. Now if you want to see one more example, let us say set of all natural numbers, and let us assume that the operation is multiplication. Now if you multiply any two natural numbers, the result is also going to be a natural number. Therefore I can say that set of all natural numbers are closed under the operation multiplication, and therefore the set of all natural numbers with respect to the operation star is an abelian structure. Okay, so that is the basic definition of abelian structure. Now from the abelian structure we go on defining the other elements, and then we go to the group, but we go slowly. Okay, fine. One interesting question is, will there be any sets with respect to some operation are not abelian structures? Which means, can you define some operations on a set which are not closed? Yes, it is perfectly possible. So for example, you can think about it like this. Let us say a set is having three elements, 1, 2, 3, and if I define S comma star, which means if I am talking about this particular set with respect to the operation multiplication, then definitely the set S is not closed under the operation multiplication. The reason is, if I take 2 into 3, if I multiply 2 and 3, the result is going to be 6, and 6 is not present there, therefore it is not closed. So we cannot call S as an abelian structure, S as an algebraic structure with respect to the operation star. Got it? So S is not an algebraic structure with respect to the operation star, and that is about the finite set. If you want an infinite set also, you can take it. Let's say we are talking about set of all integers. Okay, set of all integers, and the operation is divides. Okay, now if I take set of all operators and if I take division, the operation is division. Okay, now it is not, the result is not going, this is not going to be an algebraic structure. The reason is, if I take 2 and divide it with 3, the result is not going to be an integer. That is why set of all integers are not closed under the operation division, and so we cannot call Z, the set of all integers, as an algebraic structure with respect to the operation division. Got it? And assume that let's say we have set of all natural numbers. Okay, set of all natural numbers we have, and let's talk about subtraction. What happens now if I take two natural numbers and if I apply this subtraction, then will the result also be a natural number? Need not be. The reason is, if I take 1 and if I subtract 2 from it, then the result is going to be -1, which is not a natural number, right? So natural numbers are from 1, right? They start from 1 and go on infinity, but here it is -1. So what can you say about it? Set of all natural numbers are not closed under the operation subtraction. So set of all natural numbers cannot be algebraic structure with respect to the operation subtraction. Got it? So there are examples of sets which are algebraic structures, and there are examples of sets which are not algebraic structures. Now if a set satisfies this concept of algebraic structure, then we can extend the definition and we can find out till the groups. If it fails here itself, then it will not be a group. Okay, what is a group? We shall go slowly. I'll come back to that point. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.